So I am doing part 4 of my series on matrices, and we're going to solve simultaneous equations using matrices. So I'm giving you here two equations, 5x minus 4y equals to 23 and 2x minus 7y equals to 11. So what we can do is we can write this part, the 5, the negative 4, the 2, the negative 7 is as matrices, is a matrix 5 to or 5 negative 4 to negative 7. So that's a matrix here. And obviously the x and y can also be written as a separate matrix, 2 by 1 matrix. And if you look at the way you multiply, that 5 times x plus negative 4 times y gives you that part of that equation. The same with 2x, or the 2 times the x plus negative 7 times the y give you 2x minus y, which is that part of the equation. And we're going to let everything equal to 2311. Okay, so what is very important is we need to take this part here, the 5, negative 4, 2, negative 7. I'm going to say let that be my matrix A. Now, what we need to do here is we need to be able to do something here, because it's supposed to be that matrix A times xy equals to 23 over 11. Now, what we're going to do is we're going to try to get rid of this A. So what we do is we multiply throughout by the inverse. Remember what I said in my previous video, whenever you multiply any matrix by inverse, it gives you the identity vector. The identity vector is actually another way in matrices of writing the number 1. So the identity vector is just going to be that 1 there. So now we have xy equals to the inverse of the vector of the matrix, sorry, the inverse of the matrix of times 2311. Right, so most of the things that we need to do, we need to make sure that we write it in this format. So if we get simultaneous equations in this form, we need to write it in vector form or in matrices form. And then what we do is the xy here should be on the right or on its own, but you need to multiply 2311 by the inverse, and you make sure that that inverse is on the left side of that number 2311. Okay, so we are always going to use this result. So if we want to find x and y, we multiply the values on the right by the inverse of the given matrix. So what I'm doing is, first of all, you find the determinant of this matrix A. That gives you negative 27. I hope you can still remember or recall how to do the determinant of a vector. You can also have a look at my previous videos, how to find the determinant of a 2 by 2 vector or matrix. Right, so the inverse of a matrix is that determinant, and then inside you swap the leading diagonals, the elements of the leading diagonals, and you change the signs in the second or the trailing diagonal. And this henceforth is the inverse. So I'm just going to leave it in this form. So it's the inverse, which I have here, multiplied by 2311. So I said make sure that you keep that inverse on the left side of the number 2311. Now we're going to clean this up, but I'm going to leave the 1 over the negative 27. I'm going to leave the determinant. So I'm first going to multiply the negative 7 for negative 2, 5, 23, 11. Once I do that, remember it's row, column, row, column. So I'm going to end up with a 2 by 1 matrix. Now that leaves me with negative 1 over 27 multiplied by negative 117, 9. So always leave it in this form, the determinant, and only then divide each element by that negative 1 over 27 by 27, negative 27. So that gives me x equals to 13 over 3, which is the same as 4 and 1/3, and y equals to negative 1/3. Okay, so let's look at another one. So I have here this equations 5x minus 2y equals to 16, 7x plus 6y equals to negative 4. If you have grasped, if you have understood the previous example. Maybe you can pause the video here and try to do this on your own. Right, so I take the elements 5, -2, 7, and 6. I write them in a matrix here. And obviously here I have my xy, another matrix. And it should equal to 16, -4. All right, so if you look at 5x minus 2y gives you 16. And 7x plus 6y gives you -4. So this is row, column. Right, so what we need to do, remember I said you need to find the inverse of this vector or this matrix. Okay, what is it with me and the vector? So the inverse of, let me say, let this 5, -2, 7, 6, let it be A, let it be represented by matrix A. And its determinant is going to be 44. I hope you still remember. That is 5 times 6 minus -2 times 7, which is 30, minus -14, which is plus positive 44. Right, so now the inverse of the matrix A is going to be 1 over 44, and in brackets you swap the elements around for the leading diagonal and you change the signs for the second one. That being a -2, now it's a positive 2. This being a 7, now it's a -7. So essentially you leave it in this form. So this is the part that you're going to multiply with this particular number here, but you put it on the left side of the number as I indicate here in red. Always remember that you put it on the left side of the number. Right, so now you're going to take the 6, 2, -7, and 5, and you're going to multiply it with this matrix 16, -4. And once you do that, you should arrive at 88 minus 132. And only now you can divide by 44, multiply by 1/44. And if you do that, you're going to end up finding x equals to 2 and y equals to -3. I hope you arrive at the same answer. So I'm going to do a few questions and that you can try and also solve on your own. I'm going to do 3 questions. Question 1, you have got this matrix x2 and this matrix x5. So this here is a 1 by 2 matrix followed by a 2 by 1 matrix. And it gives you this kx after we multiply together. Now, you're supposed to find the values of k, or the value of k, if x squared plus 8x plus 10 is equal to 0. And in the second part, you're supposed to solve this equation, x squared plus 8x plus 10 equals to 0. Well, it's totally up to you, because if the question says give your answer to 2 decimal places, that means they are telling you that you're supposed to follow a certain degree of accuracy. That means this particular equation does not factorize, and you have to use either the completing the square method or using the quadratic equation formula. All right, so let's do part A then. So what you do is, let me multiply then these two here. So it's x times x plus 10. All right, so it's just going to be a one single element. Now you get x squared plus 10x equals to kx. So if you rewrite it in the standard form, it's x squared minus kx plus 10x. However, we are told that x squared plus 8x plus 10 is equal to 0. So we're then going to take the coefficients of x, that is -k equals to positive 8. Therefore, k is equal to -8. Right, so this one you can either decide to use the quadratic equation formula. So I am using completing the square method. For me it's easier, but it's totally up to you, as long as you find the answers. Right, so first I move the constant term over, and then I bring in some side work. I find half of the middle term, half of 8 is 4. And I'm going to square that, and I'm going to add 16. Right, so what I do here, the x plus 4 all squared, the 16 is already in here if you multiply these up. So on this side, I'm going to add the 16 there. And when I add -10 plus 16, I get a positive number. And because I have a positive number, I can find roots or solutions for these equations. Now, because the square root of 6, to get rid of the square root of 6 is irrational number, that is why your answer would be given as a rounded answer. Right, so one solution, obviously, if you move that minus 4 in order to isolate the x, now I put it in front of the square root because I look at that square root as an operator, but you can put it on the other side, it's totally up to you. So one answer will be minus 4 plus square root of 6, and the other one will obviously be minus 4 minus the square root of 6. So you're going to write it two decimal places. First one is going to be negative 1.55, and the second one is going to be negative 6.45. Right, my second question that I have here, part A, you're supposed to solve for x and y. Part B, you're supposed to find the inverse of that matrix. Part C is on the next slide. Please make sure that on this side, you don't get confused. You already have two matrices here equals to xy. So the xy's are the numbers. So what you do here is you simply then multiply the left side. All right, multiply these two matrices. This is a 2 by 2 times a 2 by 1. So I said 2 by 2 times a 2 by 1. So I hope you still remember what your answer would be. Obviously, the answer would be this is a 2 by 2 matrix, and this one here is a 2 by 1 matrix. So at the end of the day, what you're expecting to be left with, these two in the middle are okay, and so you need to have a 2 by 1, which is exactly what you have here. Okay, right, so we are going to multiply that part out, and let's see if you still remember how to multiply these two matrices. Right, so once you multiply, you take 3 times negative 3 plus 2 times 2, and negative 1 times negative 3 plus 6 times 2. Well, that should give you x, y. So clean that up, you get negative 5, 15, that should be equal to xy. Therefore, x is equal to negative 5 and y is equal to 15. The inverse of the matrix, remember, you are going to take the determinant. So 2 times 3 is 6, minus 4 times negative 1 is negative 4. So 6 minus negative 4 is the same as 10. So it's 1 over 10, and you swap the leading elements of the matrix around, and then you change the sign for the trailing diagonal. So that becomes positive 1, and this one becomes negative 4. So you can leave it in this form, or you can continue by multiplying throughout by 1 over 10ths. That gives you 3 tenths, 1 tenth, negative 4 tenths, and 2 tenths. You can even go ahead and simplify the other part, the 2, negative 2 5, negative 2 over 5, and 1/5. All right, so essentially this first part already contains the inverse. So this is just you carrying that 1 over 10 over by multiplying with each one of the elements in there. Right, part C, you're supposed to solve for t and for u. Right, so you need to be a bit careful here. So you have 3t u minus t 3u, and then you have another matrix 1 2, and it should equal to 10 negative 10. So first of all, let's multiply the left side. Let's multiply the left side, so it's the same like the one we did previously. And when you multiply, you're going to end up with 3t plus 2u and minus t plus 6u obviously equals to that. So this means that we now have two simultaneous equations. And because we have two simultaneous equations, we can write 3, 2, negative 1, and 6 in matrix form as that matrix there, and then also the one that we're looking for, tu equals to 10 minus 10. Now when we are here, remember, you're supposed to find the inverse in order to get rid of this. So you're going to find the inverse and multiply the inverse with this 10 negative 10. So let that be our A, and the inverse, and let that be maybe x, and this one can be our B matrix. Now the inverse of A, obviously you're going to multiply 3 times 6 is 18 minus negative 2, that's going to give you 20. So the determinant is 1 over 20. Swap them around and change the sign. And what we need to do is, in order to find this, we need to take the inverse of A, this here, and multiply it by B, the number there. So this is essentially what we have. Remember, this inverse should be on the left side of the number. Right, so you're going to multiply first the 6 minus 2, 1, 3 with that 10, negative 10 matrix. So that gives you 1 of 20 80, 20. So now you can actually distribute that 20 or divide 80 by 20 and also negative 20 by 20. Right, so once you do that, you arrive at t equals to 4 and u equals to negative 1. Right, so I have a third question here. And the first part says you're supposed to find the inverse of matrix P. And then you're told that A is a 2 by 2 zero matrix. So each element of matrix A is just 0. And you multiply 3 times that zero matrix plus B, which is the matrix 25, negative 20, negative 15, 10. And you, after adding them, you should multiply by the inverse that you already have at part A. And you should see whether you're getting to this matrix here that is given to you. Right, so the inverse, first of all, you find the determinant, which is 1 over 5, that is 4 negative 1. 4 times negative 1 plus negative 9 times 1. So just make sure that when you calculate the determinant of P, the determinant of P is going to be 4, so maybe you can put that 4 in brackets, 4 times negative 1 minus, in brackets again, negative 9 times 1. So you have to be a bit careful here. That's negative 4 here. You have negative here and negative 9. So obviously this becomes negative 4 plus 9. All right, and 9 minus 4 is equal to 5. So this part then becomes 1 over 5, which is how you start your inverse. And then you take this and swap them around, as you can see here. And obviously you change the sign, that being a minus, now it becomes a positive, and this one being a positive here now becomes a negative. All right, so remember that in order for you to find the inverse, you first have to find the determinant. So if you have forgotten to find the determinant, look at previous videos for you to be able to recall how to find the determinant of a 2 by 2 matrix. Right, so they are saying then, well, you can go ahead and you can also multiply or distribute that 1 over 5 with each element there. So I know that matrix A is zero matrix, a 2 by 2 zero matrix, so each element is 0. B is essentially 25, negative 20, negative 15, and 10 as given. So 3 times anything 0 is just going to be that 0. So now I'm going to have that 25 minus 20 minus 15, 10. I'm going to multiply it with each element here. So I'm going to advise you maybe to pause and to try to work it out and see if you get to this particular answer here. Right, so I have done the long way here. Make sure that your values are corresponding to what I have done, and you will see that eventually I get negative 1, 29, 1, and negative 19. Okay, so this brings the end of my series on matrices. I hope if you have problems, you can go back, check the previous videos that I have done under the playlist for matrices on my YouTube channel. And please don't forget to subscribe to my channel and click the notification bar in order for you to get notified every time I upload a video.